Hello, this project is a cloud-connected environmental monitoring system built using Raspberry Pi, Flask, and AWS serverless service. And the system reads temperature, humidity, and pressure data from a SenseHead emulator and uploads the reading to AWS, processes them using Lambda functions, stores them in database, and display everything on a real-time dashboard. So basically, this is my project overall system architecture. The Raspberry Pi acts as a edge device and uploads sensor readings through API gateway using HTTP request. AWS Lambda handles ingestions, processing, warning evaluation, authentication, and setting management. DynamoDB stores the sensor readings, thresholds, and user accounts. SNS is used for automated email alerts. The Flask dashboard communicates with the cloud backend and displays real-time data to users. This is my end-to-end cloud architecture, and the device layer handles sensor processing and collection, and the cloud layer handles processing and storage, and the presentation layer contains the Flask dashboard and browser interface. This sequence diagram shows the upload flow and the dashboard retrieval flow. Sensor data is uploaded to AWS first, then retrieved by the dashboard through the backend API. Now we'll demonstrate the live upload process. The uploader reads sensor value from the SenseHead emulator every few seconds and send them to the cloud backend. We can tell from the terminal HTTP 201, and that is evidence of how it works. HTTP 201 response confirms that the Lambda function successfully validated and stored into the database. And if the uploaded values change immediately when the emulator values are adjusted. And the dashboard pulls the backend every 4 seconds using the Flask BFF layer. The live readings, charts, warnings, and analysis panel are generated from AWS Lambda responses. The reading card. The dashboard shows real-time temperature, humidity, and pressure reading. Threshold lines are displayed directly on the chart. The freshness indicator. The freshness indicator shows whether the cloud data is live, recent, or stale. And this is the settings. A user can also configure threshold values directly from the dashboard. And also, the dashboard also includes a manual ingest form for testing warning without using the emulator. And now let us input something higher temperature. Oh. Now I am immediately exceeding the configured threshold to trigger a cloud-side warning. And we can tell from the temperature intelligence the trend is rising rapidly with noticeable fluctuations. And the warning logic runs in the get dashboard data Lambda function, not locally on the Raspberry Pi. And the dashboard shows a critical warning because the temperature exceeds the configuration maximum threshold. And the chat also shows the sensor value crossing the configured threshold line in real time. And actually, I've also do the SNS configuration, so I can receive a real-time warning. 0 minutes ago, you can see the pressure too high, warning temperature too high. And now let's move to the function DynamoDB. All readings um, all readings are stored in DynamoDB using device ID and timestamp keys. The latest reading uploaded from Pi 001 are visible from the DynamoDB. And we can also see the device settings and the device threshold settings are user authentication data are also stored in DynamoDB. And also, the CloudWatch was used extensively during development and debugging. These logs show Lambda processing, warning evaluation, and SNS publishing activity. And when thresholds are exceeded, SNS automatically sends an email alert to subscribed users. Authentication is fully cloud-backed using Lambda and DynamoDB. And now we can exchange the temperature max. Let me change it to like 60 degree. And we can see the settings are stored in DynamoDB and reloaded from the cloud backend. So overall, this project demonstrates a complete IoT and cloud pipeline using AWS serverless architecture, and the system supports a leaf sensor uploads, cloud-side processing, DynamoDB storage, monitoring, authentication, and automated SNS alerts. The architecture is scalable and could be extended to support multiple devices and real-world monitoring environments.